Hello everyone, welcome to JLT Academy, and our today's topic is curves. Before going to the video, please like, subscribe and share our channel. So let's start the video. In this video we are going to learn about the curves. So first of all, basically what is the curve? Curve is provided when there is a sharp corner or when we have to change our alignment, we go to the curve. Okay, we don't give the advantage to the sharp corners. We don't keep the sharp corners in our road alignment or road changing path. Whenever that we are going to change our path, okay, we don't prefer the sharp corners. We prefer the curves. Why? Because it reduces the accidents. Okay, it reduces the accident and visibility is more in the curves, and it gives comfort to the drivers. Okay, these are the advantages as generally that are the advantages. So the types of curves are either circular, spiral or parabolic. Like when we describe in the shapes, okay, when we classified in the shapes, like what are those? Circular, spiral and parabolic. As per geometry, when we go, there are simple curve, compound curve, reverse curve and transition curve. What is that? A simple curve, this is the simple curve. It has only one radius, and we can say that a curve which has a constant radius is called a simple curve. When we move to the compound curve, it is defined as the curve which has different radii and the radii are present, both radii are present one side to the common tangent. This is the common tangent we have. The radii are present one side to the common tangent and that are different. When we move to the reverse curve, the radii are present opposite to the common tangent. One radii is left side and one radii is a right hand side. That type of curve is called a reverse curve, and they may be equal or unequal. The radii are may be equal or unequal. That is called a reverse curve. When we go to the transition curve, the curve whose radius is reduced to infinity to finite value, to finite value. Let's see, the curve starts from a straight line. As we know, straight line has a infinite value of radius. It has an infinite value of radius. That value is reduces to the finite value, that is a known value of radius of a simple curve. That portion of a curve, okay, that portion of a curve is called as a transition curve. This is the types of curves. What is degree of curve? Degree of curve may be defined as the angle subtended, okay, the angle subtended at the center of an arc. This is our arc. Angle subtended at the center. Okay. This is called the degree of the curve. What is the angle subtended at the center of an arc? If of how much length? 30 meter length. If we are taking the arc length as 30 meter, then that is called fixed length of an arc. If we are taking a chord, okay, a chord as 30 meters length, that is called a fixed length of the chord. To know what is the degree of an arc, okay, degree of the curve, we have, that is our 360 degrees are divided by the 2 pi r into how much the length of an arc curve, 30 meter. By that 360 into 30 is 1000 800 divided by 2 pi r gives the value of 1718.9 by r. Okay, that is a 1718.9 by r, or r is equals to 1718.9 by d. If the degree is 1, okay, the degree of curve is 1, that curve has a radius of 1718 meters. Okay, if the degrees of this simple curve or whatever curve is 1, that curve has a radius of 1718.9 meter. Okay, hello everyone, welcome to JLD Academy, and we are going to discuss about the elements of our circular curve. Before starting the video, please make sure to subscribe the video, like, and please share the video. So, what are the elements of our circular curve? Back tangent, forward tangent, point of intersection, angle of intersection, point of commencement, and the point of tangency. These are the words that we are going to use in our circular elements. That these are the elements, and these words are we are going to use in our circular curve while we are designing the curve. Okay, what is that? The back tangent AT1 is our back tangent, and the BT2, this is our forward tangent. The tangent which is at the end point of our curve is called forward tangent, and the tangent where the curve starts is called our forward back tangent. Okay, and the point of intersection where the two tangents are meet is called our point of intersection, that is our I. And then angle of intersection, that the angle, this angle is called, angle of intersection, and this phi angle is called deflection angle. Okay, what is the deflection angle? The angle, see, this is AT1 going in this direction, but BT2 is deflected by some angle. This tangent is deflected by some angle to the previous tangent. That angle is called deflection angle. Then point of commencement. This is the point of commencement where the curve starts, and this is the point of tangency where the curve ends. These are the points. This is the curve. This is our radius r. Okay, this is the long chord. This is the mid ordinate. This is the length of the curve from T1 to T2, and suppose the distance between the two chords, if it is 30 meters, then that chords are called normal chords. If the distance between these chords are less than 30 meters, then it is called subchord. Okay, this chord and this chord is called subchord. Normally, the first and last one are the subchords, and the other ones are normal chords, and the longest chord is our this is our mid ordinate or mid chord. Okay, this is our long chord, this is the radius. Okay, we are going, I am going to write the formulas for length of curve, length of chord, mid ordinate, and apex distance. The distance I to C is called the apex distance. Okay. These four terms are asking in our exam. So I am going to write the formulas and then we are going to solve the problem. The formulas for the length of the curve is pi r 180 into phi, and the tangent length is r tan phi by 2. Mid ordinate is r into 1 minus cos phi by 2, and the apex distance is r into secant phi by 2 minus 1. If you remember these formulas, you can easily work out the problem. Okay. In the problem, he asked that find out these four: length of curve, tangent length, mid ordinate, and apex distance. And the data is given as radius and the intersection angle. To find out that, in these four formulas, we have to know the r value and the phi. This phi is deflection angle, not intersection angle. So to find out the deflection angle delta or phi, I have, that is 180 minus intersection angle. This is the intersection angle and this is our deflection angle. This total is 180. If I deduct 120 degrees, then I get 60 degrees as our deflection angle. So the length of curve is pi r phi by 180. I got the 628.32 meters. Then I am directly substituting the values. R is equals to tangent length is r tan phi by 2, 600 tan 60 by 2. Then mid ordinate is 600 into 1 minus cos 60 by 2, and the apex distance is 600 into secant 60 by 2 minus 1. So let's see what is the length of curve is from this point to this point, that is from A to B. Suppose this is the length of the curve, and then the tangent length is from A1 to I. This is our, from A to I, this is our tangent length. Then what is the length of mid ordinate? This is the length of mid ordinate. Suppose this is D, this is C. Okay, this is the length of mid ordinate, DC, that is 80.38. And apex distance, the distance between I and C is called the apex distance, that is 92.82 meters. So if you remember the formulas, you can easily calculate the length of the curve, tangent length, and mid ordinate, and also the apex distance. Thank you for watching the videos. Please make sure to subscribe our channel, and you can also download the notes from the link that is given below. Thank you for watching the video.